In this video, we'll take a look at the stack data structure, and I should probably be using the term abstract data type since we're not going to be discussing a particular implementation. So you'll often hear those terms abstract data type and data structure used interchangeably, but really if we're not discussing a particular implementation, then we should use abstract data type. So forgive me for using data structure in the discussion here. So this stack data structure, we can think of it like a Pez dispenser or maybe a tray dispenser that you'd find in a cafeteria, and I have pictures of both of those over here. So here we have a Pez dispenser and here we have a tray dispenser. So with a Pez dispenser, we have these candies here that exist inside the dispenser, and if we want to remove a candy, then we remove whatever candy's at the very top of this Pez dispenser. If we wanted to put a piece of candy in, then we would insert it also at the top. And it's the same idea here with the tray dispenser. If we wanted to take a tray here from the tray dispenser, we would remove it from the very top. If we wanted to place a tray dispenser or place a tray on the tray dispenser, we'd place it on the very top. And that's the same idea that we have with the stack data structure. So all the operations associated with the stack structure occurs on the top. So if we wanted to put something or remove something, it always occurs on the top. We're constrained in that way. So associated with that constraint, we'll normally hear this term LIFO, or last in, first out, whenever we describe the stack. So the stack is this last in, first out data structure. And what that means is whatever the last thing that we put on the stack is the first thing that will come off the stack, last in, first out. So now I want to talk about the terminology associated with the operations. We'll have a list here that just simply specifies the operations associated with our stack abstract data type or stack data structure. So the very first term or the first operation is the idea of the push. So the push is the operation to actually place something on our stack. And again, everything occurs on the top. So if it turns out that it's an empty stack, then we would be placing the very first item on the stack. If it's not an empty stack, then we would be placing that particular item on top of whatever is at the very top of the stack. And then we'd have another operation called pop. Pop allows us to remove the very top item. So push and pop are the more formal names associated with putting something on and removing something off of the stack. Typically you'll have a top operation. Sometimes this will be called the peak operation. So the peak or the top operation just allows you to examine without actually removing whatever the top item is. You may also be provided with an isEmpty operation. So we'll say isEmpty. And this just tells us whether the stack is empty or not. And this is very useful, especially if you're wanting to maybe remove all the items off of a stack. You can just set up a looping structure and say, as long as it's not empty, keep popping or whatever it may be. So we have isEmpty, and typically you'll find maybe a size operation as well. So you'll be able to get the size of the stack. So we'll be able to tell how many elements are currently on the stack. But these are the normal operations that you'll have. So let me just draw, a picture, I guess. I think most of you probably have an idea of what's going on with a stack, but I guess just to try to make things a little bit clearer, I'm going to draw a logical representation of a stack over here, and it's just going to be a three-sided figure. And we can imagine doing a push operation. I'm going to just push on some rectangles here. So I'm going to push on maybe a blue rectangle. We'll do another push operation here. We'll push on maybe a red rectangle, then maybe a green rectangle. So you can see that all these are push operations, and every time we push something, it's being pushed on at the very top. So this green thing here is at the very top. So we can imagine we always have some reference or some pointer here to the very top of our stack. And if we wanted to do a pop operation, we can just do, well, in my case, I can just do a Control-Z to undo the last thing I did. So I'm doing a Control-Z here, and that's removing. So that's a pop, that's a pop. And so now here our original blue item is now at the top of the stack again, since we popped off the green and the red item that we had. And if I wanted to push those back on, I could just use Control-Y, which is the redo operation. So that's the idea of pushing and popping stuff off of our stack. Now, what's interesting about the thing that I just did using that Control-Z and Control-Y, it's actually employing the stack data structure. So this undo and redo that you often find in a lot of different programs, be it a word processing program, spreadsheet application, really any type of application on lots of different systems, you can use the Control-Z and Control-Y to do an undo and a redo, and that's exactly what I was doing just then, and that is using the stack data structure. Another example of where you may find the stack data structure is with your browser history. So I'm going to go over here to Google Chrome and do a search maybe for stack. So we'll do a search for stack, and then we'll go to the Wikipedia entry. So we're visiting that page, or trying to visit that page, and then we'll go to abstract data type, go to that particular page, and then go to the data structures page. So what I've done here is I've built up a small history, and every single page, whenever I clicked on a link, I was basically pushing on a new page onto a stack data structure. And you can imagine going back through your history here and popping off those various items. So I imagine what's going on here is maybe we're popping off a particular page, but notice here that we can go back to the page that we were just on. We can go forward in our history. So I'm assuming that maybe we have two stacks that are actually going on here with being able to go back and go forward in terms of our browser history. I'm not exactly sure if they're using stacks to accomplish this or not, but you could imagine two stacks being used to kind of move through your internet history. Another good example for where we may want to use the stack data structure is simulating a card game. So if you think about typical card games, you would have a deck in which you would draw from the top of that deck. Again, we're constraining ourselves to only doing the operation on the top. And maybe there's a discard deck. So if we were to discard one of our cards to the discard deck, maybe we're required to discard to the top of that deck. So again, that would be a place where we'd use this stack data structure. Another example may be for prefix notation, or sometimes called Polish notation. I don't want to go into the details of that, but if you're curious about it, you can look it up and see how the stack data structure could be used for the prefix notation as opposed to our typical infix notation. So I would encourage you to maybe think of other examples of where you may want to employ the stack data structure. To summarize, the stack data structure, or the stacked abstract data type, is probably what we should really be saying, is this last in, first out structure. So the last thing that we put in is the first thing that we take out, and that all the operations are occurring on the top of the stack. So in the next video, we're going to look at C++'s standard template library support for the stack data structure and look at using these operations that we talked about today. So really, any programming language that has a decent library is probably going to support the stack data structure without you having to implement your own stack structure, and we'll have the various operations that we talked about today. So that's it for this video.